right, hi guys. We are back with the second week of solving rational equations. For these lessons, we're going to talk about solving rational equations using cross multiplication. But we're going to do some problems that are a little bit more complicated, and then we're also going to get into what an extraneous solution is in the context of rational equations, and how you can tell if the solution or solutions that you find are extraneous. So here we go. So when solving rational equations, the cross multiplication method only works for rational equations that contain exactly one rational expression or fraction on each side of the equal sign. If your equation is not in proper cross multiplication form, you may need to use algebraic operations to move its terms to their proper places. So last week, everything that we did was already in that proper form, but this week it's not. So if you take a look at number 1, you have x divided by 6 plus 5 equals 7. This is not in proper form for cross multiplication because we do not have one fraction on one side and one fraction on the other side. So what I'm going to do is I'm going to take this 5 here, subtract the 5 from each side, and so I get x divided by 6 equals 7 minus 5, which is 2. And then I want these to both be fractions. 2 is the same thing as 2 over 1. And so now I have what I need. I have a setup that I can do cross multiplication. So now this turns into a problem just like this ones we did last week. 1 times x is 1x, or just x. And that equals 6 times 2. And so we have x equals 6 times 2, which is 12. So x is 12 here. So that's what you would do if you had a situation where you had just a number on each side, but more typical is that you have multiple fractions like number 2. So in number 2, we have x divided by 2 plus 1/3 equals 5/3. Now we need to turn this into a situation where we have one fraction on one side and one fraction on the other side. So in order to do this, what you need to recognize is the two fractions here, or it could be more than two, but that have the same denominator, and put those together on one side. We can only add or subtract fractions if they have the same denominator. So if you'll notice here, 1/3 and 5/3, they both have the same denominator. So what we're going to do is we're going to get every one fraction on each side by subtracting 1/3 from each side here. So that way we get x over 2 equals 5/3 minus 1/3. Okay? And now, in order to add or subtract fractions, we need the denominators to be the same, and then you would add or subtract the numerators. So in this case, we would have x divided by 2 equals, the denominator is 3, and then 5 minus 1 is 4. And now we have a cross multiplication situation just like we had previously, and we know what to do with. So we will multiply these. X times 3 is 3x. And 2 times 4. So we get 3x equals 8, and then we'll divide both sides by 3. So x equals 8/3. Remember, you can leave it as a fraction just like that, or 8 divided by 3 is 2.6 repeating. So that would be, if you round to 3 decimal places, 2.667. So either one of those would be a fully acceptable solution. All right, number 3. Now this is getting into more of what we we're seeing in our previous week stuff where we have not just x, but a factor like x minus 4. We're going to treat this the same as we treated number 2. We want the things, the rational expressions with the same denominator to be on the same side. The x minus 4 here is that common denominator. So we've got 4, sorry. So what we'll do is we will subtract 2 over x minus 4 from each side. So we've got 4 over 7 equals 6 over x minus 4 minus 2 over x minus 4. And just like we talked about in our previous example, when we are subtracting or adding fractions or rational expressions, we need a common denominator, and then we keep that denominator as it is and subtract or add the numerators. In this case, 6 minus 2 is 4. And then we will cross multiply. 4 times x minus 4 equals 7 times 4. So we distribute, we get 4x minus 16 equals 28. And then we need to get all the x's on one side, numbers on the other, so we will add 16 to each side here. And so, 16. So 4x equals 44. And then we divide both sides by 4 to get x by itself. So x equals 11. Then let's take a look at number 4. Again, we need everything with a common denominator to be on one side. So we've got 3 over x minus 3 equals x over x minus 3 minus 3 halves. We're going to subtract x over x minus 3 from each side. So I get 3 over x minus 3 minus x over x minus 3 equals negative 3 halves. That negative here cannot go away just because we subtracted what goes first. Now notice here, if you combine and we subtract here, the denominator is the same, so that's still our denominator, but here 3 minus x, those are not like terms, so they're not combined. So keep that in mind. Then we'll cross multiply. 2 times 3 minus x equals negative 3 times x minus 3. And we distribute. 2 times 3 is 6. 2 times negative x is negative 2x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And our goal here is to get every x on one side and number on the other. There's multiple different ways that you can do this, but what I'm going to do here is I'm going to add 3x to each side. So that way I get 6 plus 1x, because negative 2 plus 3 is 1. These cancel here, equals 9. I'll subtract 6 from each side. Remember that 1x is the same thing as x, so x is 9 minus 6, which is 3. Now, notice that this one in particular was starred. The reason that it's starred is because this is where we're going to begin our discussion of extraneous solutions. Now, an extraneous solution is a solution that you get by manipulating the equation that when you were to plug it back into the original function, makes the original equation not true. In this particular case, what we're looking for, and for rational equations in general, what we're looking for are things that could make the denominator equal to zero, because we are not allowed, we know in math that we're not allowed to divide by zero. And so something that would make this equation not true would be if we had a denominator that was equal to zero, because we're not allowed to divide by zero, therefore this equation wouldn't work out. So if you look at this example, you can see that there's one denominator that's just 2. Obviously 2 cannot equal 0. But then there's two denominators that are x minus 3. So the question is, what could x be that would make x minus 3 equal to 0? Well, if x were 3, then they would both be 3 minus 3. And really all you need is one of them to be 3 minus 3, and one of them to equal 0 to know that it's extraneous. But anyway, so if x is 3, then that would make both of these denominators equal to 0, and all we need is one of them to equal 0 to know that the solution is extraneous, meaning that the equation will not work out when you substitute it in. So let's go back and look at the answer that we got for this problem. Well, the answer that we got was in fact 3 in this case. So what we're going to do is we're going to cross out that solution, and we're going to write that it was extraneous. So that is an extraneous solution. And in this particular case itself, you could also say that there was no solution because the only solution that you got was extraneous, or you could just say that the x minus 3 was an extraneous solution. Either way is okay. So typically what we'll do with these problems, and we're going to start that now, is we're actually going to check what our potential extraneous solutions would be first before we even solve the rational equation, so that we know if we get that answer at the end that it's extraneous. So take a look at example 1 here. What values would be extraneous solutions to the equation? And those are values that would make the denominator, for any of these denominators, equal to 0. So in this particular case, in this first one, 1 over x, well, if x were 0, then we would get 1 over 0, so we'd be dividing by 0. In the second rational expression here, if x was 5, 5 minus 5 is 0. So 5 would be another example of an extraneous solution. And then here, x plus 2, well, if x was negative 2, negative 2 plus 2 equals 0. So those are our 3 possible extraneous solutions. They're extraneous values because each value, or x value makes one, it could be or more, but in this case one of the denominators of the original equation equal 0. Okay? It doesn't have to be those exact words for your explanation, but that's the idea, is that if you have a denominator, or more than one, but one or more denominators, that x value would make that denominator 0, then that would be a potential extraneous value or extraneous solution. Example number 2, what values would be extraneous solutions to this equation? 1 over x minus 5 plus x over x minus 3 plus 1 over x minus 2. We don't care at all about this x in the numerator. Numerator doesn't matter to us because the numerator can be 0, and that would be fine. We're just looking for the x values that make the denominator, any one of the denominators, equal to 0. So in this particular case, x minus 5, if you put 5 in there, 5 minus 5 is 0. Here 3 minus 3 is 0, and here 2 minus 2 is 0. So those are the potential extraneous solutions for this example number 2. So what we're going to do now is we're going to solve these equations, but before we do that, we're going to actually find our possible extraneous solutions first. before we even solve anything, before we do anything, so that when we get to the end, we can quickly see if our solution is real or extraneous. So let's go ahead and do that for number 5 here. So we see that we've got 6 divided by x. That x would make x equals 0, would make 0 a possible extraneous solution because we're not allowed to divide by 0. And then the other two denominators are x plus 4. So if we put negative 4 in for x, then that would make those denominators equal to 0. So now we have those potential extraneous solutions. I'm going to go ahead and solve this. I'm going to try to get both of these rational expressions with the denominator of x plus 4 to one side. So I'm going to subtract 2 over x plus 4 from each side. So I get 6 over x equals 5 over x plus 4 minus 2 over x plus 4. So 6 over x equals, the denominator is the same and stays the same, and then we subtract the numerators. 5 minus 2 is 3. And then we are going to cross multiply. 6 times x plus 4 equals x times 3, or 3x. We'll distribute 6x plus 24 equals 3x. I am going to subtract 6x from each side here. So I get 24 equals negative 3x. 3 minus 6 is negative 3. We'll divide both sides by negative 3. So I get 24 divided by negative 3 is negative 8 equals x. Then I go back and I check to see if the solution that I got is one of my possible extraneous solutions. And it's not. Negative 8's not here. So that is a real solution, and that is my solution to my equation in number 5. For number 6, we are going to first write down what our potential extraneous solutions are. Those are solutions that make either denominator equal to 0. So in this first left case, x minus 1, well, if x were to equal 1, 1 minus 1 is 0. And then x plus 4, we literally just did this, that same one, x equals negative 4 is another possible extraneous solution. Now in this particular case, in number 6, we already have this set up exactly the way we wanted. It's already one fraction equal to another fraction, one rational expression equal to another, so we can cross multiply right away. Negative 1 times x plus 4 equals 3 times x minus 1. And then we will distribute. Negative 1 times x is negative 1x. Negative 1 times 4 is negative 4. 3 times x is 3x. 3 times negative 1 is negative 3. I'm going to get all the x's to one side and the numbers on the other. It doesn't really matter which way that you do this. I guess I will add 1x to each side here. You could have also subtracted 3x or done the numbers first. These cancel. Negative 4 equals 3x plus 1x, which is 4x minus 3. And then we will add 3 to each side. Negative 4 plus 3 is negative 1. So negative 1 is 4x, and then to solve for x, we divide both sides by 4. So we get negative 1/4, or as a decimal, negative 0.25 equals x. And then we look to see, is negative 1/4 either of our potential extraneous solutions? And it's not. So this is a real solution to this rational equation. All right, last two for the notes. First thing we'll do is find our potential extraneous solutions. Here we've got x minus 3 twice, and then this is a 2. So what we're going to do is just look at the x minus 3's. So we've got a potential extraneous solution of x equals 3 because 3 minus 3 equals 0. Then we are going to get the x minus 3's to one side. So I'm going to subtract x over x minus 3 from each side. So I get 3 over x minus 3 minus x over x minus 3 equals, and then again, don't forget that negative stays there, negative 3 halves. So we've got 3 minus x over x minus 3 equals negative 3 halves. Now we can cross multiply. So 2 times 3 minus x equals negative 3 times x minus 3. Distribute 6 minus 2x equals, distribute here, negative 3x plus 9. We will add 3x to each side here. Those cancel. So 6 plus negative 2x plus 3x is 1x equals 9. Subtract 6 from each side. So x is 3. Then we go back and we see, was this one of our potential extraneous solutions? And yeah, it was. It was our potential extraneous solution. So what that means is that I'm going to cross this out and I'm going to write extraneous solution. Because this was our only solution and it was extraneous, I could also write no solution because the only solution that I found was not real, it was extraneous. All right, and our last problem here, first thing again we're going to do is we're going to find our possible extraneous solutions. Just do that over here. We've got x here as a denominator, so that means that x equals 0 is a possible extraneous solution. 3 divided by 0, we can't do that. And then we've got x minus 4 as another denominator. If x were to equal 4, then 4 minus 4 is 0. And here we've got x again, so that's just a repeat. We need to turn this into a situation where we could cross multiply. So we are going to get the denominators of x's by themselves on one side. So I'm going to subtract 3 over x from each side. So 3 over x minus 4 equals 8 over x minus 3 over x. So 3 over x minus 4 equals 8 minus 3, which is 5 over x. And then we can cross multiply. 3 times x is 3x. And that equals 5 times x minus 4. And then we will distribute over here. So 3x equals 5x minus 20. I'll subtract 5x from each side. (3x minus 5x is negative 2x. These cancel. And that equals negative 20. And then we'll divide both sides by negative 2. Negative 20 divided by negative 2 is positive 10. So x equals positive 10. And then we check to see if that positive 10 is one of our potential extraneous solutions. And if we look, we had 0 and 4, neither of which was 10. So this is a real solution to this to this rational equation. All right, that ends the notes for this week. There are a practice problem set. Please go ahead and try the practice problem set first before you watch the video on the going over the practice problems. Have a wonderful day, guys.